What's up, Algebra 2? Here we are with day 2 of 6.5. Okay, this is the backside here of day 1, the ones that say more if time, or start here tomorrow. We're going to look at a few of these. Alright, let's look at reducing a cube root over here. A cube root. So 81 is not a perfect cube, right? It's 3, 9, 27. So that's not going to be a perfect cube. So we are going to split this one into 27, which is 3 to the third times 3. And then we've got our y to the 6th. That one was going to work out nice. And let's change our z to z to the 6th and z to the 1st. Okay, if you want to, we could change this to 3 cubed and 3 to the 1st there. So the cube root of 3 cubed, we're going to have 3 on the outside. That's going to stay on the inside. Cube root of y to the 6th, 6 divided by 3, we're going to have y squared on the outside. And we're going to have z squared on the outside, and we have a leftover z on the inside. Cube root, or our leftovers there and there, 3z. Okay, again, more with cube roots. We have y to the 5th. Okay, so I could go like 3 and then 2, but then I still have the leftover 2. I don't want to have any leftovers. What do I want this to be so that it's full and would work nice with this one, no leftovers? We just need one more. So we're going to go cube root of y, top and bottom. Okay, we got a cube root. 16, x to the 9th, y to the 1st, and then on the bottom here we got a cube root of y to the 6th. Okay, cube root 16, 2, 4, 8. 8 would fit in there. 8 times 2. 8 is 2 cubed, so I could rewrite that. We got 2 cubed times 2 to the 1st. X to the 9th is going to work out. And then we just have y to the 1st. On the bottom, we have our nice y to the 6th that we worked so hard to get. Okay, the cube root of 2 cubed is going to be 2 on the outside. That 2 is left over. 9 divided by 3, we're going to have x cubed on the outside, and that y is left over. Cube root of 2y was left over on the inside. Okay, the whole point of doing all this was to make it so this was nice, and that this one would come out nice on the bottom, and we'll have y squared on the bottom. Pretty nice. All right. I think we're going to be okay with just those two for today. We'll move on there and get into the actual new stuff for today. All right, foiling with radicals. Okay, so it's going to be the same process. We're just going to have some more things to keep track of. So when we're foiling with radicals, and I do first times first, we're going to do outside numbers, or sometimes I call them regular numbers or big numbers, times radical numbers. So regular times regular, radical times radical. So we're going to have 4 times 3 for 12. Radical 3 times radical 2 is going to be radical 6. Okay. Then the outsides, 4 radical 3 times negative 6. 4 times negative 6, we're going to have negative 24. Radical 3 with nothing over there, so it's just radical 3. Then we've got 5 radical 2 times 3 radical 2. It's a positive 15 radical 4. Yep, we'll take care of that 4 in a minute. And then we have 5 radical 2 times negative 6 for minus 30 radical 2. Okay, we can take care of this one. The square root of 4 is 2. 15 times 2 is 30. 12 radical 6 minus 24 radical 3 plus 30 minus 30 radical 2. Okay, none of these have the same radical, so we can't combine them. The only thing maybe we could do is it'd be nice if we had some order to it. Either work forwards or backwards from like the size of the radical. So if we want to go biggest radical first, we have the radical 6, then the radical 3, then the radical 2, and then like the normal number. Or sometimes maybe you want to go this way, the normal number first, then the radical 2, then the radical 3, then the radical 6. Some kind of order maybe would be nice to have. So let's do that. Let's go 12 radical 6 minus 24 radical 3 minus 30 radical 2 plus 30. Okay, so we didn't have any that we were able to combine here. That's not going to be the case over here. Some things are going to be able to combine. So let's have you give that one a shot. Go ahead and push pause and see how much of that you can do on your own. All right, welcome back. Let's see how we're doing. So 2 radical 3 times radical 3, we're going to have 2 radical 9. 2 radical 3 times negative 2 radical 2, we're going to have minus 4 radical 6. 5 radical 2 times radical 3, we got plus 5 radical 6. And 5 radical 2 and negative 2 radical 2 minus 10 radical 4. Okay, so these have the same radical. Negative 4 radical 6 and 5 radical 6. That's like having a negative 4x and a 5x. You can put those together, and that should just be one x in the middle there. 5 radical 6, yep. Minus 4 radical 6, yep. So we're just going to have a plus radical 6 in the middle. Okay, 2 times radical 9, well, the square root of 9 is 3. So that's going to be a big 6. And then we have square root of 4 is 2. Negative 10 times 2, we got minus 20. We can put the 6 and the minus 20 together. We got minus 14 plus radical 6, or you could go the other way around, radical 6 minus 14. All right, so why are we learning those? Why are we working on these? They're going to come in handy here when we're simplifying fractions with square roots on the bottom plus something else. If it was just one single square root on the bottom, we've had plenty of practice fixing those. Okay, we know it's bad math grammar, bad math etiquette to have a radical in the denominator of our final answer. So you multiply top and bottom by that radical 5. Well, now when there's another thing under there, if I went by radical 5, yeah, that makes that nice. But then when I multiply this one by radical 5 too, the radical's still in the denominator. So we got a special trick we use with that. It's called conjugates. It means the same thing, but opposite signs in the middle. So I'm going to multiply top and bottom by radical 5 plus 1. The exact same two things, opposite sign. Okay, so we get no big deal on the top. Well, I'm out of room there. Let's go down here. We'll have 2 radical 5 plus 2. No big deal up there on the top. Now on the bottom, pay attention here. On the bottom, pay attention here. It was just like these. We're foiling, see? We're foiling with radicals. So it's going to be radical 5 times radical 5. We got the square root of 25. So that's going to be nice. Plus radical 5 minus 1 radical 5. Negative 1 times 1, we got a minus 1. So by doing the exact same things with opposite signs in the middle, okay, we're guaranteeing that we're going to multiply these two together, and they're going to come out nice. So that one will have a square root. And then when we do the radical 5 times 1, and then the opposite sign times radical 5, those two things cancel out. So there's no more radicals there. And then we do the back thing times the back thing, and we get a nice number there. So that would have been 5 minus 1. So we have 2 radical 5 plus 2 over 5 minus 1 is going to be 4. Even number, even number, even number. All three pieces are even. So we can divide by 2 and have a final answer of radical 5 plus 1 over 2. Okay? Let's have you hit pause and give this one a shot over here. Let's have you hit pause and give this one a shot over here. All right, welcome back. Let's see how you're doing. All kinds of bells today. All right, so same two things with the opposite sign. So this one was a plus. We're going to go minus in the middle. Okay, and we have to do the same thing to the top and the bottom. All right, foil that out. No big deal on the top. We got 3 radical 3 minus 6. Okay, let's see what happens here on the bottom. Square root of 3 times the square root of 3 is the square root of 9. You might be in a place where you're comfortable just jumping right to regular 3 there. Minus 2 radical 3 plus 2 radical 3 minus 4. Okay, so that's going to cancel. Square root of 9 is going to be 3. 3 minus 4, we're going to have negative 1 on the bottom. This does get a little tricky. Okay, so how to simplify this? All right, so we got, if we just had a 1 on the bottom, right, we wouldn't need the bottom. It's just going to be the same thing as the top. We got a negative 1 up there. So I'm going to go super slow here and break it apart for you. When we have these kind of fractions, you break them apart. This would be 3 radical 3 over negative 1. And then we have minus 6 over negative 1. Right? And then we can put them together because they have the same denominator and would be right here. So separately, it's a lot easier to do this correctly. When they're pushed together, it looks smaller and it looks easier, but kids also will make a silly mistake and only change one thing. So this over negative 1 would mean this is negative. Negative 3 radical 3. And minus 6 over negative would turn this into a plus 6. So the trick here when you're dividing this fraction by negative 1 is that it flips both of them. Okay, it flips both of them. All right, and one last one. This one has square roots for both spots on the bottom. Let's see if that makes a difference. So again, we want to use the same two things, but opposite sign. So we're going to use a plus in the middle. Okay, across the top here, we're going to get 4 radical 3 plus 4 radical 2. Okay, here comes the bottom part. That's the interesting part anyways. Radical 3 times radical 3, we got radical 9 plus radical 6 minus radical 6, so cancel, minus radical 4. Okay, square root of 9 is 3, square root of 4 is 2, 3 minus 2, oh, it's just going to be a 1 on the bottom. Just a 1 on the bottom. So there we are. All right, kids. Best of luck. Let me know if you got any questions. We'll see you next time.